Alright, so this is problem 3 of the tear-off section. Problem 3 is a related trig problem, so we have to read this out. A boy standing at the end of a pier, which is 12 feet above the water, is pulling on a rope that is attached to a rowboat in the water. So they give us a picture. Here's the boy pulling on a rope attached to a boat. Here's the water, and here's the pier. If he's pulling the rope in at 6 feet per minute, how fast is the boat docking, which is moving towards the pier? So how fast is this boat moving towards the pier when it is 16 feet from the pier? Okay, so tips for related rich problems. Number 1, reread the problem. Always reread it until you finally understand what's going on. Then state what is given. So pretty much just put like given, and for example, they're telling you that the boy is standing away from the pier that is 12 feet above the water. So he's standing here, and this distance here is 12 feet. So for example, given, we'll call the pier y. So we'll call this distance y. Y is 12. Okay? Water. Okay, it's pulling on a rope that is attached to a rowboat in the water. Okay, so far we have y equals 12. If he is pulling the rope in at 6 feet per minute, so we'll call this r. Give everything variables. Since this is a triangle, by the way, let's go back to this. State what's given. So that's what I'm doing right now. I'm stating what's given. Draw a picture. They did not provide one. In this case, they did provide one, so you don't have to draw it. Well, you can redraw it like I did. But if they do not give you the problem, always redraw it. Always draw it. It's very important, and you get to see it. So that's good. And finally, 4, find an equation that relates all the variables. So what I'm doing here is I'm putting y as the pier. Since this looks like a triangle, I'm going to state this is r. So this is your r of your triangle. Now I'm going to call this x. So everything now has a variable. And now, if they give me something, I know if it's in terms of r, y, and x. So we already know that y is 12. So that's this part of the triangle, the distance from the water to the pier. What else? If he is pulling the rope in at 6 feet per minute, so he's pulling the rope at 6 feet per minute, so that's a change in r. So dr dt is equal to 6 feet per minute, so 6 feet per minute. So minute is time, feet is r, some distance. How fast is the boat docking? So how fast is this boat moving this way? So in the x way. So what we want is we want to find dx dt. So what is this when it is 16 feet from the pier? So we want to, when x is 16 feet away from the pier. So that's when x is 16. So we have y 12. So this is 12. We have x, which is 16. And we have the change in r, which is dr dt is 6. We want to find the change in x when x is 16. Now, number 4 says find an equation that relates all the variables. So that's our next step. We stated what was given. We have our picture. Now we need an equation that relates all these variables together. Okay, so if this looks like a right triangle, right? So right triangle, what equation can we use that relates everything together? Well, Pythagorean's theorem, r squared is equal to y squared plus x squared. Okay, so r squared is equal to x squared plus y squared. Now, r is changing and x is changing, but y is fixed. As the boat moves and you're pulling the rope, y is still 12. This distance always stays 12. So this equation becomes r squared equals x squared plus 12 squared. Because 12 is this distance is never moving or changing. The only thing that's changing is the pulling of the rope and the moving in of the boat. Okay, so now we have r squared is equal to x squared plus 144. So now in a related rates problem, we want to take the derivative of this side in respect to time. So take the derivative of the left side in respect to time. So we do dt of r squared, and we do dt of x squared plus 144. if we do that, the derivative of r squared is then 2r times dr dt, since r is not t. And the same thing here, so this would be 2x times dx dt. And the derivative of 144, a constant, is 0. So it would be plus 0. Now, we want to solve for dx dt, so we want to divide both sides by 2x so we can have dx dt by itself. Okay, so then that's gone, and the 2 and 2 is gone. So what are we left with? We're left with r divided by x times dr dt is equal to dx dt. Okay, so we have dr dt. Dr dt is given, that's 6. We have x. X is 16, so we have that. We're just missing r. But we can obtain r because we have 16 and 12. And we know that r squared is equal to 16 squared plus 12 squared. So we take the square root of both sides. We get that r is equal to the square root of 16 squared plus 12 squared. Okay, so that's the same thing as saying, let's see, 16 is 4 times 4, and we have, so this is squared, plus 12 is 4 times 3, and that's squared. So we can take out, let's see, 16 and 4, take this out, 4 squared and 4 squared, we take out a 4 squared. So take out a 4 squared, 4 squared, 4 squared, and you're left with 4 squared, 3 squared. So that's 4 squared plus 3 squared. Okay, and the square root of 4 squared is 4. So then we have r is equal to 4 times the square root of 4 squared is 16, 3 squared is 9, 16 plus 9 is 25. Square root of 25, but the square root of 25 is 5, so you have 4 times 5, and that's 20. So we have 20 there. Alright, so r is 20 then. So now we do have r. So we have r, x, and dr dt, so we can solve for dx dt. So dx dt is equal to 20 divided by x, and x is 16, and dr dt is 6. Okay, so let's simplify this now. Okay, so this is, let's see, 4 times 5 times 3 times 2. 16 is 4 times 2 times 2. So 4 cancels 4, 2 cancels 2. That's left with 15 over 2. So dx dt is 15 over 2. What are the units? Feet per minute. So that means that the boat is approaching the pier at 15 divided by 2 feet per minute. All right. So that's that. So very important, reread the problem if you don't understand it the first time. This is the second time you understand it. Again, reread it until you understand. State what is given then. Draw a picture if they do not provide you with one. Then find an equation that relates all the variables. So y, x, and r in this case. The equation that relates all these variables is the Pythagorean theorem.